So, so what I want to do right now is I want to quickly go over what Bernice has gone through and just remind you of the preamble that we are looking at. This is a company. It's called Brukutu Ventures. They produce local gin. And recently they've realized that lots of new entrants are making competition tough. So management now asks some people to find out the factors that determine the demand. They are already aware that quantity demanded here is affected by price. And normally, I'm sure you all know about this. But apart from price, there are other factors that can also affect demand. And one of those factors are income and then complement price. The price is P, the complement price is C, then the income is M. Now we know that these variables are dummy variables. We also know that, we know that these variables are numerical variables. But we also know that apart from these numerical variables, there are other variables that are dummy. The numerical variables are the first four, including the dependent variable, which is scale. Apart from that dependent variable, there are other variables that are numerical in nature, which affect the quantity demanded. One of them is price. One of them is complement price. Okay. One of them is income. These variables, as you can see, are numeric. But LU is a dummy representing urban, which is coded as 1 here. And you will notice that when you look here, it's coded as 1. And it's coded again as 1, but then its reference category is rural. And rural is coded as 0 because all reference categories are coded as 0. There's another variable apart from location, and that is occupation. There are 3 levels of occupation, and these occupational levels are teaching, fishing, and then trading. Now, you can see that OT has been coded for teaching. OTR has been coded as 1 for trading. But there was no coding for fishing, which means that fishing is a reference category, and it is the one that will have the 0. To see that, when you go to occupation teaching, wherever there is teaching under occupation, this has been coded as 1. Okay, so you can see 1 here for the first one. When the next one is fishing, you can see that under teaching, this has been coded as 0. When the next one is teaching, you can see that it's been coded as 1 there. So under the dummy for teaching, OT, anything that is not teaching is coded as 0. Now, this is not for exams, but this is for your research when you are doing it. And the same thing goes with occupation trading. Under the occupation trading, anything that is not trading is coded as 0. When you come to the final factor that can affect the quantity demanded of gin, it is religion. And there are 3 kinds of religion: Christian religion, religion Muslim, and religion Buddhist. But you can see that the code here has been for only religion Christian and religion Muslim, which means that the Buddhist is a reference category. What that means is that anytime I talk about Christian, I'm talking about Christian in relation to Buddhist. Anytime I talk about Muslim, I'm talking about Muslim in reference to Buddhist. And so Buddhist becomes a reference category. Now, the data has been split into 2. Let me take you to the Excel, just as you have all opened. So I'm taking you to the Excel. There are 2 sheets. One is called Brukutu Coded. That is the one I'm having here. Now, Brukutu Coded is just the one I've just explained. All those that are dummy variables are coded as 0 or 1. but then the numerical variables are having their actual numeric numbers. There's another sheet. It's called Brukutu R or Brukutu data. We'll deal with that one later. For now, we are going to generate a correlation matrix and then generate a regression result. To do that, I'm going to do it with you. Those of you who have opened your laptop and you have your Excel on, just as I have mine on here. You are going to work with me. For those of you who don't have, you got to have. Go over this and then handle it as it is. For those of you who have, you got to move at a very nice pace with me. But at any point when you are stuck, tell me no. But you got to be at a faster pace with me. So the first thing we are going to do is to generate a correlation matrix. We'll talk about that because there are questions I will ask you. 6 questions I have to ask you today about those correlation matrices. But first, let's generate it. The first thing you're going to do is to click at the top of your screen, the data tab. At the top here, you'll see a data tab, data tab, data tab, data tab. Click on that. When you click on the data tab and then you look on your far right, you will see something known as data analysis. You see it here at this section here, data analysis, data analysis. If you don't see data analysis, raise your hand. You will see data analysis after clicking data tab. If you don't see data analysis, raise your hand. If you don't see data analysis, you raise your hand. Normally, if you don't see data analysis, what it means is that you have not been using data analysis. So for those of you who have raised your hand and you don't have data analysis, work along with me. Work with me now. This is what you're going to do. What you are going to do is you are going to find and invoke and bring down data analysis. So click on the file on the top left, file, top left, file, top left, file. Then scroll down to the bottom, you'll see options or Excel options. Click it. Options or Excel options. If you do that, the Excel option parameter dialog box will pop out. You can see mine here. In the list on the far left panel, you will look towards the bottom. You will see add-ins. Add-ins. Click on add-ins. Click on add-ins. After clicking on add-ins, on the right, you will see analysis toolpack. This analysis toolpack might be in your inactive application add-ons. But wherever it is, you will see analysis toolpack. Click it. Click the analysis toolpack. When you click it, it will turn blue. When you click the analysis toolpack, it's going to turn color blue. Once it turns color blue, come to the bottom, you will see something called Go at the bottom here. You will see Go. Click on Go. A pop-up will show. In that pop-up, you will see analysis toolpack right there. There's a little box on the left of it. Click, tick it, tick the box. Mine is already ticked, but I'm on ticking mine and then ticking it again. So once you tick it, you click OK. And when you click OK, now you should see data analysis at the top right. So now when you click on data tab, on the far right, you should see data analysis. I hope you did. If you didn't, you can let me know. Now that you have your data analysis, lower your hands. Lower your hands if you have it. Good. Many of you have done that. Now click on data analysis. Move along with me. Click on data analysis. Excellent. In the list, A pop-up will come. Look for correlation. Look for correlation and double click it. Look for correlation and double click it. After double clicking, you will see that this place is empty. Okay, the place is empty. You see, there is something called input range. Input range. Input range. You see the cursor blinking in there. If the cursor is not blinking, click that little box. The cursor should be blinking there. Now, what the input range means is that everything you have in your data as an input has to be in there. And what do we have in our data? Well, on top of my screen, you will see that we have kill, P, C, M, LU, OT, OTR, RC, and RM. We're going to bounce all of them into that input range. How do you do that? You will click first the kill and hold it. Click and hold the cursor and drag it all the way to RM, just as I'm doing. Hold it, and keep on dragging it down to the end of the data set. Keep dragging it down. When you exceed it like that, come back and keep holding it. Keep holding it. If you mistakenly release your hand, go back and then start again. Inside the input range, you should have A141. That is the entire data set. Once you are done, tick labels in first row. Tick labels in first row. Tick labels in first row. And then tick output range. Tick output range. When you tick the output range, you will see an empty space. The cursor will be blinking there. Click inside that empty space. And then we are going to scroll up a little. Scroll up on the edge. And just go and select any empty space to the right of RM. That's where you want your results to be. So I want to select J1, cell J1, cell J1. And the moment I did that, you can see that in the output range, you will have cell J1. Beautiful. You are done. Click OK or enter, and your correlation matrix will be released. Pow, like that. Your correlation matrix is highlighted. Don't remove the highlight. It has so many decimals. Don't worry. We need to clear those decimals and make it just 2 decimals. You're going to make it just 2 decimals. So to do that, click on the Home tab. Click on the Home tab. Click on the Home tab. And then bring your eye to the center of your screen. You will see General at the top. You will see General at the top. Not far from Under Help. You will see General. There's a little arrow near General. Click on that arrow. There's a little arrow near General. Click on that arrow. You will see Number. Choose Number. You will see Number. Choose Number. Once you choose Number, all the many decimals will turn to 2 decimals. And your correlation matrix is in full gear. I'm about to ask you some 6 questions on this. So this is how you generate a correlation matrix. This is how you generate a correlation matrix. Who is not clear? Now, this correlation matrix, we are going to talk about it. But before we do that, I want us to quickly generate a regression result just below it. To do that, go to the beginning of your data. Just scroll left like this and come to the main data set. All right. Now, we are going to do regression. To do that, click at the top. Data tab at the top. Data tab at the top. Data tab. And then once again, go to the far right and select data analysis. Select data analysis. Once you select the data analysis parameter dialog box will pop. Scroll down, you will see regression in the list and double click it. Scroll down, you will see regression in the list, double click that regression. Once you double click, a pop-up will show. A pop-up will show. In that pop-up, You will see input Y range, input X range, and so many other things. Let's start. Click on the white space, the little box on the right of the input Y range. Whilst the cursor is blinking, let me explain what the input Y range is. Any regression you are doing, it has a dependent variable, an outcome variable, a response variable. This variable is the recipient. It is the one being influenced by multiple independent variables. The dependent variable is one. It is the Y range. So once you identify which variable is your dependent variable, that is the one that will go into this range. Well, you will know that our dependent variable here is Q. That's our dependent variable, Q. So that is a variable that is supposed to be inside the input Y range. So we're going to pick the Q alone and put it into the input Y range. How do you do that? Well, watch it. Once again, you should just click on only Q and drag it down, only Q, drag it down, only Q, drag it down. We are dragging it all down till we get to the bottom. Once you get to the bottom, you stop, release your hand, and you will see that you will have A1 up to column A41. All of them are inside the input Y range. Like I said, if you are lost, you let me know. You raise your hand, you let me know. So you should have your input Y range in the A1 column A41. Then click the input X range, the white space to the right. This will be in your exam. So it's important you are following, it's important you are understanding, it's important you are asking questions. So once you click on the input X range, the X range deals with all the independent variables, all the independent variables. Let's remind ourselves, what are they? The independent variables are P, price, which affect the quantity demanded. C, complement price, which also affect quantity demanded. M is the income of the people, that also affects the quantity demanded. LU is a dummy variable, which is location urban, and that is also affecting the quantity demanded. Occupation, there are three of them: occupation, teaching, OT, OTR, and then the reference category, which is the fishing. All of these are also affecting. And then finally, religion. Religion Christian, and then religion Muslim. All of these have been coded. We are going to pick only the independent variables into the X range, not the dependent variable. Remember, the dependent variable is Q. Now move away from Q, come to P, and then move all of them to the right-hand side. Freddie, I'll come to your question, okay? Now let's scroll it down, scroll it down, scroll it down. And then once you exceed the number, come back to the original. You will see that all of them are collected inside the input X range. Okay, Freddie, ask a question. You can unmute yourself and then ask your question.
Yes, sir. So in my Excel, I'm not seeing the input S range like you have. I actually have columns and then rows. I don't know if after I have inputted my Y range, I should click rows instead. Because when we were inputting the Y range, the columns were highlighted. But I couldn't find the X range, so I don't know.
You have the pop-up.
I can't find it.
Do you have the regression parameter dialog box?
Yes.
Do you have it just as I have it here?
I have.
I
have correlation.
Do you have this pop-up where you have regression written at the top? This little box, do you have it?
No, I have, what is written on the top is correlation.
Yeah, so it means that you didn't go ahead and do the regression when I said go and click data analysis and select regression.
Okay. Then let me do that and see, please.
Yeah. All right.
Thank you, Doc.
Yeah, welcome. Okay, so what we should do now is that now we are going to, we have indicated our input X range. I hope you all got that one. Once you are done, tick labels, tick it, and then come to the next section called output range. Select the output range, and then select the output range, and we want to indicate which cell you want the output range to be. I want you to put the output just below the RM on column J, just below the RM under column J. So click any cell under column J, just under column J is enough. And in my case, it has represented itself as J11 in the output range. Yours might be J12, J13, anything under column J. And once you are done with that, click OK. Click OK. And that will generate a beautiful regression result. You have to follow what I'm doing because you will do a similar thing in your assignment and in your exams. So in this result, you will notice that the results that you are seeing right now, it is in so many decimals. So once again, we want to convert the decimals to just 2 decimals. To do that, click on the Home tab, choose General, like we did for the correlation, and select Number. Home tab, choose General, and that's it. Job done. So you've been able to learn how to generate a correlation matrix and how to summarize a regression result, all in Excel. We shall do the same thing in R. Well, R is much more advanced. It gives us more information than just this. But for now, we are going to ask some questions on the correlation. So I'm going to show you the correlation, and then we are going to answer some questions. Other than that, if you have any question, let me know. I hope that many of you are not joining this thing because I said it's coming in the exams now. But I know that's the case. All right, let's answer some questions on the correlation. So this is a correlation matrix. A matrix is an array of rows and columns. Okay, so this is a correlation matrix that you can see. At the top of the correlation matrix are all the variables that you need. These variables are the same variables you have on the other side. Okay, so the same variables is what I'm having here. There are 6 questions I'm going to ask you. And there are similar 6 questions that I will ask you under correlation. Under regression, there will be 13 questions I will ask you. I will not do that today. I'll do regression next week. But today, I'm going to ask you 6 questions on correlation, the similar 6 questions that you get in an exam. Pay attention. Learn how to generate a correlation matrix and the regression result by yourself. Everything that I've gone through this time today, you will have to tell me the same thing. So I hope you followed. All right. Now let's ask some questions. Before we start, let me just tell you some few things. You can see that the correlation shows the relationship between variable on the top and variable on the far left. Every variable on the top is the same variable on the far left. If the variable is itself, the correlation is said to be perfect? Let me explain. If the variable is itself, the correlation is perfect. A perfect correlation or a perfect correlation coefficient is where the correlation coefficient is equal to 1. So suppose I say that A and B, by the way, the word A and B is a pair. A and B is a pair. And then B and say D is also another pair. The correlation between them will never be 1. So let's assume that this one is 0.9. And let's assume that this one is negative 0.86. But the correlation between A and A will be 1. The correlation between A and A is equal to 1.00. So that is 1. And that sort of correlation is what we call perfect correlation. This is a pair. Now, I want you to tell me which of the correlations we have here are perfect correlations. Who can tell me which correlations do we have here that are perfect correlation? Now, the way you got to read it is just read the top part and match it against the far left part. Okay? So you read this part against that part, this part against that part, and then where they meet, if it is 1, it means it's perfect. And if it is perfect, it means that the correlation equals 1. So give me one correlation that is perfect. Okay. Tanko. Is it Tanko? Yeah, Tanko.
Yes, Doc.
Yeah, give me one.
So Q and Q.
And the value is what?
1.
Give me another one.
P and P.
And the value is what?
1.
Give me another one.
C and C, and the value is also 1.
Now give
M
me
and M.
one.
M and M.
Okay.
And LU and LU.
That's okay.
OT and
Now you're
OT.
flexing your muscle. That's okay. So that is what we mean by perfect correlation. So a perfect correlation is a correlation coefficient that is 1. Please note there's a difference between perfect and highest. Highest means that it's closer to 1, but it's never 1. Perfect is 1. Now let me ask you some few questions. I want you to identify some of the correlations I'm about to mention. If I should ask you to tell me the correlation coefficient between C and OT, what will be the value? Between C and OT, what will be the value? Evans, make sure you know before your hand is up. Between C and OT, what is the value? All right, let me go to Kweku.
So it will be negative 0.29.
Negative 0.29. So what he did is that he looked at C here. Watch, some of you look at C here, and then you look at OT, and you say that, oh, it's not there. But that is not the answer. Not that it's not there. It's because the correlation, if you look at it left and right, left and top, and it doesn't match, you should do top and down. So the fact that C and OT is not here doesn't mean it's not there. It's rather C and OT, that is where you see it here, and that is negative 0.29. So that is how you assess correlation. That's why you got it, assess correlation. Now, give me another one. Let's say I want you to tell me the correlation coefficient between RC and RM. RC and RM. What is the coefficient? What is the correlation coefficient between RC and RM? Patrick does it. Is it Patrick? Yeah. Patrick. Patrick, yeah, Patrick.
Roughly 0.53, negative 0.53.
Very good. It's always important to bring the negative. Always important. Even if you use the absolute value in your mind, you still have to mention the negative. Excellent. So now let me go to my second question. Remember, the first question I asked you was perfect correlation. My second question, write it down. Identify 3 pairs of variables that are strongly, identify 3 pairs of variables that are most strongly correlated with the response variable. Identify 3 pairs of variables that are most strongly correlated with the response variable. Identify 3 pairs of variables that are most strongly correlated with the response variable. Most strongly correlated with the response variable. First of all, which variable is a response variable? Write your answer down for me. Which variable is a response variable? I don't need a hand raise for this because I'm coming to proper hand raise. Which variable is a response variable? Response. Very good. DV. That's kill. Excellent. Kill. So kill is a quantity demanded. That is a response variable. Now follow me here. The question is, identify 3 pairs of variables that are strongly correlated with this kill. 3 pairs of variables that are strongly correlated with this very kill that you have just spoken about. So which variables are strongly correlated with kill? Now you can raise your hand. I want the first pair. See, the question says identify 3 pairs. So I want the first pair, the second pair, the third pair. And remember, in order of the most strongly. In order of the most strongly. So let's start. Yusuf or Patrick, one of you.
Hello, Doc.
Yeah, go ahead.
So I can see CQ.
You always have to mention it as something and something.
Okay. C and Q.
And you have to
LU
mention the number. Don't wait for me at all. Mention
okay, C and Q 0.72, Q and LU 0.71, and Q and M 0.61.
Okay, that's wrong. Let's go to
Q and CR, sorry.
You don't need to rush. Okay, that is why I give you time to think through. And when you are wrong, you are coming to change your answers all through. Don't worry, another person will get it. Okay. So tell me the 3 pairs of variables that are most strongly correlated. Julian, analytic.
We have Q and T, negative 0.87, and then Q and OTR, negative 0.78, and then Q and RM, negative 0.76.
Perfect answer. Excellent. Beautiful. That is it. So the first one is this value here. That is negative. Okay? That is negative 0.87. And then you mention it as P and Q. The second one is this number, is the numbers that are guiding you, negative 0.78. The third one is negative 0.76. It has to be in that order. The other thing is that when you mention the one on the left first, and you mention the one on the top second, all the rest must follow the left first, the top second, the left first, the top second. That is it. That is what we mean by variables that are most strongly correlated with that. And it is not P kill. It is P and kill. Now, who can tell me those variables that are least correlated instead of most correlated? Tell me the 3 pairs that are least correlated, all 3 pairs that are least correlated. Who can tell me that? You must have the numbers in your mind. In fact, I'm not even so much. Once you can tell me the numbers in order, I know. Least correlated. You see, the first one is least correlated with a dependent variable. That was the first one. Now I'm asking you to tell me the least correlated with the dependent variable. The previous one was most correlated with the dependent variable. Now tell me least correlated with the dependent variable. Who will crack that code for me? Evans, Ampao, Prince, one of you should tell me the answer. Evans.
Okay, so Q and OT, negative 0.11. Q and M 0.61 and Q and RC 0.70.
Perfectly executed. Okay. So you should always know that you will get the highest or the lowest. That's the question. The question is going to be like, you should always know that the highest correlated, the lowest correlated, the most, the least, the most, the least. Next question. Identify 3 pairs of variables that are most multicollinear. Identify 3 pairs of variables that are mostly multicollinear. Identify 3 pairs of variables that are mostly multicollinear. 3 pairs. Now, to be able to answer this, and I hope you've written the question, understand that multicollinearity deals with independent variables alone. So any column here that is part of the dependent variable is not part. The dependent variable is not part. So the question is asking you to identify only those variables that are within the independent variable section alone. Independent variable section alone. Okay, in order of the most, the highest, the next highest, the next lower. And it has to be the highest because the question says mostly multicollinear. So which 3 pairs of variables are mostly multicollinear? All 3 pairs. In fact, when you tell me the numbers, I know you can tell me the pairs. So what are the numbers? Okay. Mostly multicollinear. 3 pairs, mostly multicollinear. The first pair, the second pair, the third, the fourth, the fifth, and then the last one. Who can tell me? Who can crack that code for me? Prince, unmute yourself and tell me.
Doug, I think the first one will be 0.76.
The first one is 0.76. That's what he's saying. Okay, so I've circled that here. Let's go.
Then the next one will be negative 0.74.
Negative 0.74. And
then we also have 0.73.
Very good. You have negative 0.73. Now, sometimes some people, they don't take their time and then they'll go and mention wrong numbers. For example, there will be a lot of temptation for a person to choose this one, 0.71, and the person will be wrong. So what you want to do is to open your eyes. That's a key point. And remember that you may have a matrix, a correlation matrix that is way more than this. And when it is way more than this, you got to open your eyes wide and then identify that. Excellent work, Prince. That is how you tackle it. Now, what if I had asked you 3 pairs of variables that are least multicollinear? Least multicollinear. Who can give me the first one? Least multicollinear. Paul Matzo. Yeah.
Negative 0.03.
Negative 0.03. So this is the one he's talking about. Negative 0.03. Yes? Is that all? Paul, your job is not to mute yourself. Your job is to finish all of it.
All right. The next one is 0.05.
That is 0.05, and that is this. And of course, I'm sure you know the pairs, don't you?
Yes, please.
Final one.
0.11.
0.
Sorry, negative 0.11.
Negative 0.11 is wrong.
Oh, no, it's rather 0.3.
But don't worry, say no because I said it's wrong. So you go back and then you go and reshuffle your mind because to be honest with you, that is wrong. Who can tell me the correct 3 pairs? The correct 3 pairs. He started nicely, ended quite not nicely. Who would tell us the rest, especially the last one that he missed? Michael.
Okay, negative 0.03, the first one.
Yeah.
0.05. The last one is 0.14.
0.14, and that is correct. Okay. Now, the reason why this last one is better than this negative 0.11 is that the negative 0.11 is part of the dependent variable. And I did tell you that multicollinear variables are not dependent, they are independent variables. So anything on the column of the dependent is not part of it, no matter how small or big it is. So these are your pairs. Okay, the last question. Identify 3 pairs of variables that are least correlated. So this time I don't want to go to the most. Least correlated. I want you to know that this question is different from the previous one. The previous one says 3 pairs of variables that are least multicollinear. But this one is saying that 3 pairs of variables that are least correlated. Who can give me those 3? And tell me the difference. In fact, who can tell me the difference between this question and the previous one? And then the person should answer them for me. This one and the previous one. What is the difference between least correlated and then least multicollinear? Evans.
Okay, so the least correlated deals with the multicollinear deals with only independent variables, but the second question you asked deals with both dependent and independent variables.
So what will be added and what will be removed from
so
the
0.14 will be removed and 0.11, negative 0.11 will be added.
Perfect, excellent. You are great, you are wonderful. I mean, that's how you do it. Okay. So the difference between this one and the previous one is that the previous one is multicollinear. So multicollinear, it deals with only the variables that are in this section alone, But then this last question, correlated variable, it includes the dependent variable. That is how you tackle this. Now, next time we are going to look at regression, but I want to show you quickly how to do the regression in R, how to load data in R, and then that's it for today. How do you load the data into R in a regression? Now, once again, you need to know this because you have a whole chunk of assignment on this. And second, again, you need to know this because you have to demonstrate that in the exams. In other words, you're not going to use a laptop for that, but you're going to remember what you have done to say it. So it's important you follow through what we're about to do. So what I want you to do now is to open your R Studio. Open your R Studio. Open your R Studio. Open your R Studio. Now, let me open mine and show you. So if you open your R Studio, you will get something like I have on my screen. If you open your R Studio, you'll get something like I do have on my screen. Now, your R Studio might be in 3 parts like this, like what I have here, 3 parts. Now, those of you, when you are able to open your R Studio, please let me know. Raise your hand and let me know. When you're able to open your R Studio, you raise your hand and let me know something. Eight people have opened their R Studio. 9 people have done that. If you open your R Studio, you let me know. If you open your R Studio, you raise up your hand and join the queue. So those of you who have raised your hand, don't put it down, keep it up. Okay, now, for those of you who have raised your hand, you will have something like a little box on top of each other. And that shows that the thing is in 3 parts. But the actual thing is that the interface is supposed to be in 4 parts. So just click on this little box. And when you do that, you will notice that the thing will be in 4 parts, with the first command window being white. With the first command window being white and the number 1 written there with the cursor blinking there. The number 1 is written there, the cursor is blinking there. If you open your RStudio and you join the club, you raise your hand. So if your cursor is blinking, by the way, this part where the cursor is blinking is called a command window. The part below that, the box below that, where I am highlighting now, is known as the console. The console is where your results are shown. On the far right, bottom right, you have some packages, files, plots, help, viewer, and several other things. Now, we are going to type a command, and this command is going to bring the data from Excel to R. Type it along with me. The command is JIN equal to read.deleme into brackets, double apostrophe, clipboard. Some of you may have typed this thing before from last week. Clipboard. Once you have finished typing this, go to your Excel. By the way, you can lower your hands now. I've taken the screenshot. Lower your hands now, for those of you who raised. And please go to your Excel. Let's go to the Excel together. And then choose the Brukutu R sheet data. In your Excel, instead of the Brukutu coded, choose the Brukutu data, the R. That's other sheet. That other sheet should have information like I have here. Please, there was a typo under the location, occupation, religion. Under the occupation, yours is OCCU. Make it OCC. The occupation, make it OCC. We are going to take this data from R and send it from Excel and send it to R. We're going to take this data from Excel and send the data to R. So I want you to highlight the data. Control A will highlight the whole data set. Control C will copy the whole data set. Control A will highlight the whole data set. Control C will copy it. Once you've copied it, come to RStudio, where we were. Go back to the RStudio. Don't paste it all. Just go to the RStudio. When you go to the RStudio, the command that you typed, which is GIN, equal to read.deleme, double apostrophe, clipboard. On top of that command, you will see run. On top of that command, you will see the word run, run, run. Click run, click run. Once you click run, the cursor will move from number 1 to number 2. Once you click run, you see, remember that you have copied the data. So the moment you click run, the name of the data in the command will show itself at the bottom. The name of the data, which is GIN, will reflect at the bottom, which is inside the console. So the console will show it written blue, and that means the data has been loaded. And once you click on run, the cursor will move to number 2. Let me see by hands, those of you who have done that. Let me see by hands, those of you who have done that. Let me see by hands, those of you who have done this. Okay. Now, to be sure that the data is actually in the memory of R, type GIN again at number 2, type GIN, J-I-N, and run that again. Type GIN, J-I-N, and run that again. And when you do that, you will see at the bottom that the data is showing beautifully, like mine is showing right here. You will notice that the data is showing beautifully, like mine is showing right here. If yours is showing, keep your hand up. If yours is not showing, lower your hand. This is how you bring a data set from Excel to R. And next week, what I'm going to do is that next time, I'm going to show you how you can generate descriptive statistics, correlation matrix, scatter plot matrices, and a regression. And after that, we're going to answer 13 questions related to that. For now, just type summary in command number 3. Type summary, bracket, and inside a bracket, put in GIN. Type summary, bracket, inside a bracket, put in GIN. And run it again, and run it again. It will give you the summary statistics of your data. It will give you the minute portion of the summary statistics of your data. There's a better command, which is called describe. We shall look at it next time. That will give you a better descriptive statistics of your entire data set. Ladies and gentlemen, welcome to the story of the R Studio. And on that brings us to the end of the entire caboodle. I know you may have some questions, so I'm going to stand here. In case you have any question, let me know, let me address it for you, and we will be rock and rolling.